Okay, the concept of ions, an ion is an atom, it's an individual atom that is no longer neutral. It's going to either have more pluses, what are the plus particles? Protons. So it's going to have more protons if it's positive, or if it's negative, it will have more electrons. Okay, now, a couple things we need to remember about ions. We're going to take our good friend magnesium here, okay, Mg. Now, Mg has an atomic number of 12. What does that mean? It means if I say that Mg, if I wanted to do a Bohr-Rutherford here actually, okay, and I would say this, 12 plus. 12 plus is Mg. That means that there are going to be 12 protons in one atom of magnesium. So if I was drawing the Bohr-Rutherford, atom here, it's going to have 3 shells. So I would go 1, 2 on the first, then 1, 2, 3, 4, 5, 6, 7, 8, and then we're left with 1 and 2. It's got a valence number of 2. In its outermost shell, it's got 2 negative electrons. Okay? And I use the analogy that a proton is the size of this room, and an electron is the size of my cherry here. So which do you think is going to be easier to move around? That tiny little electron, right? So protons never, ever leave an atom. Whatever number that atom is supposed to have, whatever its atomic number, that is always the number of pluses it's going to have. Now, if I look at magnesium, how many valence electrons does magnesium have? It has 2 valence electrons. Okay? What is a full shell of valence electrons in the third period? Third period has, somebody said it, 8. A maximum of 8. Sodium has 1, magnesium has 2, aluminum 3, silicon 4, phosphorus 5, sulfur 6, chlorine 7, and argon has 8. That is period 3. Row 3, okay, it's going to have 3 rings, right? And it's going to have 2 on its outermost ring. Now, a full shell is 8 valence electrons, right? Is having 2, is it easier to get rid of the 2 or get 6? It's easier to get rid of the 2. So often you will see something like magnesium, okay, and this is why we went over ionic bonding, but it is not on your exam. We went over ionic bonding to show that when a normal, and this is a neutral atom, it's a neutral atom, why? Same amount of electrons and protons, right? Protons equal to 12, electrons equal to 12. All right? Now, when this sucker bonds with something else, all right? And we're going to make a nice, easy bonding here. We're going to bond it with sulfur, who's in need of 2 electrons. We're going to make a nice 1-to-1. Okay, we're not going to talk about magnesium chloride because that one's 2 chlorines, okay? Now, if I look at sulfur, sulfur is number 16. Okay, so 1, 2, 3, because it's still in the same period. And we'll change color here. We'll go with purple. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are my 16 protons in the middle and my 16 electrons. Okay? This has how many valence electrons? It has 6 valence electrons, right? It's missing one here, and it's missing one here on that shell of 8. Okay? So is it easier to get to my 8 valence electrons, or is it easier to give up its 6? So what ends up happening here, all right, is we end up having these two guys. This guy, oops, didn't want to do that. Okay, this guy's going to move all the way over here, and this guy is going to move over here. Okay, and these guys are actually stuck together now. Okay, if I wanted to do this like so, I could just take this whole, whoops, that's not what I wanted to do. Take this whole guy right here and just bring it nice and close. Okay? So these guys are bound together. And actually, I didn't draw that in right, but who cares? Whatever. Now, what ends up happening here, this is a neutral molecule. Right? It's got the same number of protons in the whole molecule as it has electrons. It is neutral. But should this couple here ever break up, okay? Should this molecule ever split apart, then sulfur is going to keep its actual electrons that it got from magnesium. It doesn't give them back, ever. Okay, I look at this as a couple, and I say, oh, well, someone gave someone a bunch of gifts. When they break up, you don't take the gifts back. You gave them, you lose them forever. Okay? So if these guys are now free floating, they are no longer neutral atoms. Okay, let's make this guy a little bit smaller, and then let's make this guy, whoops. Oh, that was smooth. Cool. Let's make that guy a little bit smaller. Now, if I look at this, magnesium still has, magnesium still has its 12 protons. But how many electrons does it have now? It only has 10 negatives now because it lost 2 in the breakup. So now it's going to have 2 more pluses than negatives, so it will be a positive ion with a charge of +2 because it has 2 more pluses than it has negatives. Okay? At the same time, good old sulfur here still has his 16 pluses, but he now has how many negatives? He's got 18 negatives. And if you add these together, you end up with 2 minus. Therefore, sulfur becomes an ion that has 2 more negatives than positives. Okay? This is what you need to know for ions. This is it. So, just to add now, this would now become Mg2 plus. Okay, the 2 shows that it's an ion. The 2 plus shows that it's an ion, and by how much? Whereas sulfur is 2 minus. Okay, and some places might write -2 instead of 2 minus. Whatever, potato, potato. Okay?